Okay, first of all, what is polynomial interpolation? In a simple way, we have a set of points and we know a polynomial will result from connecting these points. So for example, 1, 4, 2, 9, 3, 12. So 1, 4, 2, 9, 3, 12. So we know some sort of polynomial will result. By polynomial interpolation, we can predict what this polynomial will be and therefore discover other values on the graph. So it's kind of a prediction. It's very useful. So let's take these points and see how can we predict the values for x 1/2. Okay, so you want to predict the values, let's say over here, what the y value will be. So that's just a picture to help you remember what it is. So step 1 would be to actually know what kind of equation do we want and what degree at most is it. So the question asks, we are given the points, please find interpolating polynomial p of x of degree at most 2. So we have degree 2 at most 2. And then estimate value corresponding to x 1/2. So step 1, what do we want? So we want p of x. So we're gonna write r0 plus r1 x1 to the power of 1 plus r2 x2 to the power of 2. So that's basically, it can go on and on. So that's your basic thing. And you stop writing this when x has a degree of 2. Okay, so the step 2 is we plug these points in the equation. So p of x, first x is 1, p of 2, p of 3. r0, this is obviously the same, plus r1 plus r2 plus r3. Oops. r1, okay. And then x1 is the same. So 1 to the power of 1, 2 to the power of 1, 3 to the power of 1, plus r2, and then x to the power of 2. So 1 to the power of 2 plus r2, 2 to the power of 2. Okay. This will be obviously 1, this will be 4, this will be 9. And, okay. Let's just move the camera. Okay. Okay, this equation, value for x is 4. Here value for x is 9. Here value is 12. Step 3. Construct matrix out of this. So 1 1 1 1 2 3 1 4 9 and then 4 9 12. Okay, that's our matrix. When we reduce it to reduced row echelon form, we will get 1 0 0 minus 3 0 1 0 8 0 0 1 minus 1. So that's our reduced form, and we know this is R0, this is R1, this is R2. So we know R0 equals minus 3, R2, R1 equals to 8, R2 equals to minus 1. Here, here, and here, okay? So we are asked to find the value of y for x equals 1/2. So our original equation, we have to just plug in those values, plug in x, and then solve for this one on this side. So solve for y value. So we have our template equation. You don't have to include that, but just to make sure. Okay, so that's our basic equation. Now we're just gonna plug in x was 1/2, r0 is minus 3, r1 is 8, x 1/2 plus r2 was minus 1, x2 1/2, and then squared. So we're plugging in this value for x, and then these values here, here, and here. After we reduce it, it's going to be minus 3 plus 4 minus 1/4, and it's going to equal to 3/4. So p of 1/2, p of x equals 3/4. So that's our x value, that's our y value. So the new point that we found on this polynomial with a degree at most 2 was this.